Starting with two definitions, enlargement and reduction. An enlargement is increasing the size of an object. Anyone want to guess reduction, what it means? Decreasing the size of an object. Two little examples. I'm going to highlight the original triangle. There might be some extras up there, check. Did the new triangle get bigger or get smaller? Bigger, so that's an enlargement. I'm going to highlight the original truck. If there aren't any up there, then we're out. Is the new truck smaller or larger? Smaller. Third definition is scale factor. It's the number we multiply by. Number. If we want to do an enlargement, the scale factor has to be greater than 1. And if you're not going to remember what that symbol is, use the words greater than. If we want to do a reduction, it has to be less than 1. Again, if you don't like the symbol, write out the words. So we're going to start with a pretty easy diagram, and we're going to do an enlargement with a scale factor of 2. Method's right here in the box. We're going to multiply the coordinates of the original object by the scale factor and graph them, and then we're going to label the new coordinates with primes. First thing I'm going to do is label the original points. I'm going to pick A at the top, B on the right, C on the bottom, D on the left. Mathematicians, not creative people. Alan, 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 Alan. Hey, can you take your earphones out, please? What are the coordinates of point A? So where is the location of point A? Well, coordinates need two parts to it, x-coordinate and y-coordinate. So 0 to the left and right, 3 up. Coordinates of B. Coordinates of B. 0. Coordinates of C. Almost. 0, minus 3. And coordinates of D. Minus 3, 0. Okay, so those are the original coordinates that made up this diamond shape or this square. Because the scale factor is 2, all we're going to do is multiply them all by 2. Now we talked about this earlier in the unit is I can't call this new point A. I need to call it something else. So what's the notation we use when A changes? With the prime. So we call it A prime. So 0 times 2 and 3 times 2? 6. What am I going to call the new B? B prime. 3 times 2? 0 times 2? 0. The new C is going to be called C prime. 0 times 2? Negative 3 times 2?
Positive.
No, because it's negative times positive. d prime is going to become -6, 0. And now we're just going to plot the new point. So 0, 6 means from the origin it's no units left or right, 6 units up. B prime is 6 units to the right, no units up and down. C prime is 0 units left and right, 6 units down. And D is at -6, 0. And what are we going to do with those 4 points? Join them. There's our first enlargement. Bless you. Did the new square get bigger? Yep, that's an enlargement. Really, it's that easy? Yes, it's really that easy. Same figure, same original points. We're going to order them in the exact same way, A, B, C, D. Just remind me again, what was the original coordinates of A? 0, 3. B. C. And D. This time, instead of multiplying by 2, we're going to multiply by 1/2. What am I going to call the new A? And I'm just going to throw it on the other side of the graph because I don't want to run into my graph. 0 times 1/2, that's the easy one. What's anything times 0? 3 times 1/2. We'll have you multiply fractions, way back what we did in February. How do we multiply fractions? Top times top and bottom times bottom. What's under the 3 that we don't see, but we know it's there? So imaginary 1. So top times top is 3 times 1, which is? And the bottom, 1 times 2? 2. And if you don't like the fraction, you can put it into decimal. What is 3 divided by 2 in decimal? So you could put 1.5 if you prefer when we count those points. Sometimes decimals is a little bit easier. Turn to someone in front, behind, or beside you. List out B, C, and D prime. Write out the coordinates of B, C, D prime. I feel like you're done already. B prime will be 3/2, comma, 0. C prime? I hear mumble, mumble, mumble. -3 times 1/2. -3/2. And d prime? And again, if you'd rather put the decimals, that's fine. Okay, so let's put a prime. What do I do with 0, 1.5? How do I plot 1.5? Between 1 and 2, so I'm going to go up a box and a half. B prime's over a box and a half. C prime's down a box and a half. And D prime, guess? Where am I going to put D prime? Over a box and a half. What do we do with those 4 new points? Join them. There's our first reduction. Did the new one get smaller? That's a reduction. Example 2, we're going to do the same thing, except we're going to make the initial object. It's going to be a funky object, whatever we come up with. So give me a coordinate point. Pick a point. I need an x and a y. 2 values. Okay, let's plot 5, 0. Someone else, give me another point. Well, we just did 5, 0. Let's mix it up a little bit. Okay, let's plot B. Let's pick something that doesn't have a 0 in it. Maybe some negatives just for fun. -3. 1. Give me something in the third quadrant. -4, -2. Okay, let's connect the points. Here's our starting object. Never ask during the notes, because what do I say every day? I always say wait till we're done. So we're going to do an enlargement of 3 and then a reduction by a half again. So what's A prime going to be down here if we're doing a scale factor of 3? Scale factor of 3. A prime. 15, comma, 0. B prime. Comma 9, good job. C prime. And the last one, D prime. -12, -6, agree? Now, we probably don't want to jump by 1s, because take a look at 15. Are we going to be able to fit that on our grid? No. So what do you want to jump by to be able to fit 15 on our grid? 3s, okay, so this will be 3. Next space will be 6. And then This is painful. And after 12. And then, and the last one. And the other side's going to be the negative, same values. Going down the same. Let's just review, why did we change the axes on this one? So that we could fit all the points. Otherwise, there's no way we could fit 15, 0. Okay, so 15, 0, A prime. 0, 9, B prime. Negative 9, 3, C prime. And negative 12, negative 6, D prime. Now, if we were doing an enlargement, why does it look like the exact same size as our original? It's because the scale changed. So we made the scale smaller in order to fit it on the grid. How are we doing so far? Thumbs up, thumbs to the side, thumbs down. Good. Okay, let's do the second one. We're going to do the reduction. Reduction of a half. So A prime is going to become Cam, put it away, please. I don't have mine. You don't need a calculator to times by a half. Okay, so 5 halves, comma, 0. And if you don't like the 5 halves, what can we write instead for the decimal? 2.5. Okay, that's a choice. You can either do decimal or fraction. B prime. 0 and 1.5. I think 1.5 because it's 3 halves. Okay. C prime. Could you sigh louder and maybe look more bored? Because that's not offensive and rude.
I wasn't sighing, I was just...
Just breathing in a sighing manner. C prime. And D prime. Do we need to change the axes like in this one, or will we be able to fit it in? We'll be able to fit it in because it's getting smaller. Okay, so 2.5, so 2 squares and then half a square. There's your A prime. 0, 1.5, so 1.5 squares. Negative 1.5 and 0.5. Okay, so C's in the middle of a box. Oh, I should have gone up there. Whoa, don't copy that. Should have been positive. And D, negative 2, negative 1. Did it get smaller?
Yeah.
That's reductions and enlargements. I'm going to give you some worksheets.